Okay, so to recall, right, to check if a table is a linear function, we need to find the slope between consecutive points, and if all of them are equal, then the function is linear. So this means that we would find the change in x and the change in y, divide them, and then see what we get. So for part A here, the change in x is 1 for every one, so plus 1, plus 1, plus 1. And for the change in y, 9.3 minus 12.6 would be negative 3.3. Right, because we're always drawing kind of like right to left here. This is also negative 3.3, and 2.7 minus 6 is also negative 3.3. And so this means that the slope for each one of these, it'd be the change in the y divided by the change in x. So negative 3.3 over 1. So slopes, right, I'm doing all of them. Negative 3.3 over 1 and negative 3.3 over 1. And so all of these are just negative 3.3. So the function's linear, because the slopes between consecutive points are all the same number. So to figure out the formula, you already have the slope for the function. The only other step you need would be to find the vertical intercept, but you actually already have that as well, because we told you that the point 0, 12.6 is in the table, and that's precisely the vertical intercept. And so b would be 12.6, and so y would be negative 3.3, negative 3.3x plus 12.6. That would be your linear function. Part B is a little bit more difficult because you aren't given the intercept itself. If it is linear, right? We have to check that first. So from negative 1 to 1, your change is plus 2. 1 to 3, it's plus 2. And from 3 to 5, it's also plus 2. Your change in the output, or f of t here, 0.4 minus 0.1 is positive 0.3. 0.4 to 0.7 plus 0.3, 0.3, and also plus 0.3. And so your slope for this one would be change in y divided by the change in x, which is 2. And so your slope is 0.15. And like I said, we don't have the intercept in the table, so we have to solve for it. And using what we did in the last two sections, we know that y is equal to 0.15 t plus the vertical intercept b, and we can just substitute in any point. So say the second one. So negative 0.4 is 0.15 times 1 plus b, and this would mean if you subtract 0.5 from both sides, that b is 0.25. And so your linear function is 0.125 t plus 0.25. Now let's do another one. So for part C, your change in input is 1.5 here, plus 1.5, plus 1.5, plus 1.5. So we have a constant change in input, or in other words, the run is 1.5. Your change in outputs for here, it's plus 6. Here it is minus 6, and plus 6. So your rise is either positive 6 or negative 6. And so this means that the slopes are not equal. Because for the first point, it would be, well, positive, right? And then negative. So it's turning up and down. So because your slope is not constant, so it's nonlinear. This cannot be described by a linear function. And the other two problems are the same. One shortcut you can do to work on this is if you have, if your change in inputs are the same number and your change in outputs are the same number, which is not the case here, right? But if it was at the bottom, then it would be linear. So something like, for part B, we had always had 2, we always had 0.3. That means when you divide them, obviously you would all get the same number, but for part C that fails. So it's a shortcut you can keep in mind as well.